Hello everyone, my name is Jayakera. My ID number is 24CS001 and my topic is grouping anagram using a SMAP with sorting. What is anagrams? Understanding letter rearrangement. Anagrams are words formatted by rearranging the same letter in the different order such as actor transforming into a co-star. They are commonly used in word game and text analyze for fun and puzzles. Algorithm step key process to group. Step 1 first sort each word alphabetically. Then this ensure that anagrams share the same representation, allowing for easy comparison and grouping based on their sorted form. Step 2 next utilize an undirected map with the sorted word as the key. This enable efficient storage and retrieval for words that are enables linking them together. Step 3 finally iterate throughout the map to store and print the group word. Print only those group containing more than one word to showcase actual anagrams effectively. પછી related code and related example output. Key takeaway on anagrams are words with the same letter in the different order. Sort each word. Use a key group in a hash map. Undirected map store all anagrams group. Time complexity is of n multiply of k multiply log k. Output show each anagrams groups clearly.
Hello, my name is Priya Aghera. My ID is 24CS002. Today I am going to present my topic grouping anagram using tree data structure. So, our problem statement is print all anagrams in a set of strings. So, what is anagram? Two strings are called anagram if we can create one by rearranging the letter of others using all characters. Exactly one. For example, actors and coasters, altered and related, auction and education. All these pairs are use the same letters just in a different order. For this problem statement, we have two methods of DSA, hash map plus sorting, and another one is tree based. So I am going to use tree based solution in this presentation video. So the objective of our problem statement is to group all anagrams using a tree data structure to apply sorting and traversal concept from DSA to visualize how tree help organize world efficiently. Importance. So, practical use of trees in a text processing and word grouping help understand real world application of a data structure. And the conclusion is the tree based method in efficient, simple, and conceptually strong. It proves how data structure can solve real life world application problems effectively. So the approach overview of our tree-based solution is first, sort each word because anagram have the same letters, just arrange differently. Insert the sorted word into a tree. Each character become a node in a tree. Sort the original word at a leaf node. All anagrams end at the same leaf. And the fourth, travels tree and print group. Whenever a leaf has more than one word, those are printed as an anagram. Here, this is our code. Our code divided into main three parts. First is group anagram, second is insert, and the third is the print anagram. And this is our main function. In this main function, first we create a vector of words such as auction, actor, and streaming, etc. These words are the data we want to analyze. Next, we call the group anagram function, which groups words that have anagrams of each word that have the same letters in a different order. So, In this code, we defined a tree node. Each node has a map of child node for character and store the world at a leaf. This structure help efficiently store and grouping our anagram. In this part of code, we have anagram group function is used to group all anagrams from a given list of words. First, we create an empty tree to store a words. Then, for each word, we sort it character alphabetically. For example, actors ACORST and coaster ACORST. Sorting help us to identify words with the same letter. If and then it call a insert function to store a sorted word into a tree character by character while keeping the original word at the same leaf node. After insertion, we call print anagram function which print all words that are anagram together. Using a tree this way make it efficient to group and retrieve anagrams from the list. Here is insert function which insert a word into a tree. We start at the root node and move character by character. For each character in a sorted word, we check if a child node exists. If it doesn't, we create a new node. If it does, we follow the same path. For example, when inserting actors element, we create a node. We inserting all the elements until we reach to a last node. This is our leaf node. Here A, then C, then O, R, S, T. And while insertion of coaster, the path is already exist. When we insert A, root have already child A, and then the current is on A. While insertion of C, the A node have its child C, so the current is moved on C. While insertion of O, C have its child O, so current is on O. Same as last. And at last, append the original word coaster in the word string and leaf have two words, actor and coaster. In this part of code, we have print anagram function, which recursively travels the tree in pre-order and print all anagrams together. First, we check this base case. If the current node is null pointer, we stopped and return. Then if the current node world string has more than one word, we print it since it contains group anagrams. After that, the function recursively calls itself and for old nodes, going through the tree until all nodes are visited. This way, we can efficiently print all words that are anagram together. The diagram shows the flow. Check the null pointer, print world if present, and then recursion for a children node until the entire tree is traversed. This shows the step-by-step flow of grouping anagram using a tree. We started by initializing an empty tree. Then for each word in an input set, we sort its character. For example, oxen and education both become A, C, D, E, I, N, O, T, U. Next, we insert the sorted word into the tree character by character and add leaf node, we store the original word. After processing all words, the leaf node for you contain both words, auction and education. Finally, we traverse the tree in pre-order. Whenever a leaf node has more than one word, we print them. This efficiently groups and display all anagrams together. Now we analyze time and space complexity. For each of n words, sorting that word take O of k into log k time and inserting the sort word into tree take O of k time. Since sorting dominated, the total time complexity is O of n into k log k. In worst case, if there no common prefix, we may need a new node for each character of every word, leading to O of n into k node in a tree. Sorting the original word at the leaf node also require O of n into k space. So all over the time complexity is O of n into k log k and the space complexity is O of n into k. Advantages of this tree-based solution is first, natural grouping. The tree structure inherently group all anagram together at the same leaf node. Second, efficient prefix sharing. If multiple words share a common sorted prefix, memory is saved because the nodes are reused. Third, deterministic order. A pre-order traversal of a tree produces a consistent, predictable output, often alphabetical based on a sorted word. Finally, scalability. This approach works efficiently even with a larger number of words, making it suitable for a bigger database. Real world application of group anagrams using a tree. First, in a world game and puzzle, it can automatically find anagrams helping in games like Scrabble. Second, in text analyzing, it can group world to study pattern and language. Third, search engine can suggest alternative spelling or expanded queries. For example, searching for a lesson would also consider a silent. Fourth, in a data deduplication, it helps identify duplicate entries that are just rearrangements of each other. Finally, it bioinformatics similar approach can find related gene or protein sequence where anagrams are analogs to different permutation at the same element. Compare the tree-based solution and hash table solution. Both have similar time and space complexity. The tree map sorted word into a path in a tree, while hash map use a bucket solution. Trees are more complex to implement but provide a deterministic output and can save memory with a set prefix. Hash tables are simpler but may use more memory and give non-deterministic order. So this is all about tree-based solution of our problem statement. Thank you.